So in this video, we will be covering operations with functions, which is unit 2.4, part of functions in the IB Math AA course. So let's say we have two functions, f of x equals 3x minus 2, and g of x is equal to x squared plus 5. Now let's say that we want to find the sum of these functions. We can write that as f plus g of x is equal to f of x plus g of x, right? Because we need to find the sum. So this would equal to 3x minus 2 plus x squared plus 5, which would be x squared plus 3x plus 3. This is simple enough. So the sum of two functions is simply just adding to the two of them together. Now we can do the same with the other operations. So let's have a look at this table. So this first one is what we just did. F of x plus g of x is f of g plus x. F plus g of x. Subtraction is the same thing. Multiplication is also just f times g of x, and the division is f over g of x. Okay, so that's simple enough. Now let's move on to finding the domain when we have two functions. So let's say, as another example, we take f of x as x plus 2, and we'll take g of x as root x. So the domain for this one is x is all real numbers, and the domain for this one is x is all real numbers, but x has to be greater than or equal to 0. So this is the domain for each of these functions. Now to find the combined domain for either the sum, product, or difference, it doesn't matter, for all three of them, so for sum, product, and difference, for all three of these operations, the domain of the combined would be the intersection between these two domains. Now, so for the first one, for f of x, we know that the domain is just x is greater than, it's just x is all real numbers. But for the other one, we do have a specification is where x cannot be 0 or smaller than, x cannot be smaller than 0. So the combined domain for this would then become x is all real numbers, but x has to be greater than or equal to 0, because this still applies to f of x, because f of x is all real numbers, so obviously it includes numbers that are 0 and greater. But this one can only include numbers that are above 0. So this would, the common factor between the two domains is x has to be greater than or equal to 0. But let's say we have, so this is for sum, product, and difference. Let's say we have the quotient, right? Let's say we have division. Okay, so let's say we have division. Let's say we have f of x is the same. Let's say it's still x plus 2, and g of x is still root x. Now, when we have f of x over g of x, our denominator cannot be 0. So that already eliminates one of the values that we had for the intersection of the domain before. So our domain before for the combined, for the three operations was x is all real values, but x has to be greater than or equal to 0. Now if we have the division, we cannot have x equal to 0. So therefore the domain would then simply become x is all real numbers, but x has to be greater than 0. This would be the domain for our division. Because for division, we need to keep in mind that the denominator can never equal to 0. And that's pretty much it for the operations with functions. It's pretty simple. We can look at an example. Let's say we have f of x equals to x plus 3, and g of x is equal to 1 over x minus 2. Let's say we need to find the domain of the difference f minus g, that's a minus, of x. So the domain, first let's look at the individual domains. So the domain for f of x is all real numbers. And the domain for g of x is x is all real numbers, but x cannot be 2. So therefore, the domain of f minus g, okay, so we can take that as domain f and that as domain g. So the domain of f minus g would be x is all real numbers, but x cannot be 2, because once again, that is the common factor between them. This question didn't ask us to actually subtract the two functions, it just asked for the domain, so that is what we had to do. And that's basically it on operations with functions. Thank you.